Next up, we're going to take a look at particle instancing with geometry. And this is a pretty common feature. Oftentimes people want to use the actual particle motion to manage large crowd systems and behaviors. So a typical example could be a crowd of people in a city, or a flock of birds flying, or fish. I'm sure you've seen a lot of these different scenarios. We're just going to take a look at how we can, how it's implemented in XSI and how you can use it. So in this case, we've got a simple particle being emitted with a curve acting as a goal, and we've got a simple scripted event that's making the particles follow along the curve. So the first thing that we want to do, obviously, is to model our geometry. So in this case, we've got a B object, and if we look at the way it's been set up, it's all under one hierarchy. And the important thing to consider here is to orient your geometry properly so it'll align along the particles as you want. So in this case, we have the B facing along the Y direction, and that's going to give us the correct behavior we want. The next thing is the setup with the instances. You need a group, and that's actually what it uses to actually determine what to render. So we've created a group with the B object in here, and it's a really simple matter to move objects in and out of that group later as you need. So to actually access the different instancing features, what we want to do is just go into the P type, and it's from here we're actually going to select all the instancing options. So on the last tab, we've got instancing, and I'm just going to enable that. Now we're asked to pick an instance group, so I'm just going to pick the group that was created with the B. Now that gets added to my instance group. Let's just move forward a little bit here. So if we draw a region, you can see here we've got all the B's instanced properly. The one thing we got to consider is the rotation. So for the rotation, we can actually pick from particle or none. So none will just take the actual orientation of the original geometry. From particle, we'll obviously look at the rotation of the particle. So in this case, it's important to make sure we've got the rotation set. So if we go to the General tab, we've got the rotation options here. And what I want to do is say rotation align on velocity. So this means the B's will always follow the direction the particles are traveling in. So if we draw a region there, we should see something a little better. So there you go. You can see all the B's are following their motion properly. The next thing we want to look at is the scaling. So I'm just going to set the OGL display here from null to bounded box, and this gives you a good idea of the actual size of the particles. So in this case, we've got by particle size. And what that does, it actually takes the size of the original geometry and multiplies by a factor determined by the particle radius. So in this case, and something to mention here when you're setting up the size of your actual instances, is it's a good idea to use the interparticle avoidance options. So you actually never have your particles overlapping the same physical space. So we've covered this in another section, but it's really useful, especially in the case of using instancing. So by particle size, you can see as we go into the radius and adjust this, and let's just recompute that. So you can see the actual instances are quite a bit bigger now that we've doubled the actual radius. The other options we have is to set the scaling based on the actual bounding box of the particle size. So you can see here we basically create a bounded box that represents the particle radius, and we non-uniformly scale the geometry to fit within that bounding box. So in this case, clearly we've got things quite a bit smaller. The next option is pretty similar, but it does a uniform scaling to the particle bounding box. So in this way, we preserve the actual proportions of our original geometry. So that's pretty much all the features with the instancing. And yeah, that's about it. That's a look at particle instancing.